Hi, everybody. This is Talking Digital Industries, the podcast for technologies and trends that drive industrial enterprises. And I'm your host, Chris Brow. Now, today we're going to be talking about design simulation software and how it can be used to drive electromobility and help manufacturers to become a digital enterprise. Now, let me introduce my guests. On the one side, we have Katrien Wyckaert, who is responsible for strategy and innovation for the Simcenter portfolio, the digital twin for the product performance optimization using simulation and test. Katrien, are you there with us?
Yeah, I'm here. My pleasure to be in this podcast.
And on the other side, we also have Magnus Edholm, who is the Siemens expert for helping companies drive digital transformation. Magnus, welcome back to the podcast.
Thank you very much, Chris. It's great to be here and also to meet Katrien again. It's amazing how often our paths are crossing the last couple of months. So thank you for having me.
I'm going to start off with the first question. Are you driving electric yet? Do you have electric vehicles? I mean, electric mobility is big in Europe. And the country with the largest percentage of electric vehicles is currently Norway. Still a lot of potential. But are you driving electric already, Katrien?
Yeah, I've been driving both mild hybrids and electrical. I will not call out the brands here, but it's great fun actually to drive electrical.
How about you, Magnus?
I've had a hybrid for a longer time, and now I'm looking into the use of an electrical car. But I'd love the feeling, surely. But to me, it's more the infrastructure, the charging situation. So, but hopefully, in a not too distant future, I will have the opportunity because I think it's a smooth way of driving. I like the feeling very much.
Yeah, absolutely. Anybody who's ever driven an electric vehicle before, I think has the same kind of feel and opinion. It's really smooth, something completely different. The first time you get into it, it is really like a wow experience for sure. Now, electromobility is exciting for drivers, as I just mentioned, yet for the automotive industry, it's a huge change, probably the biggest paradigm shift in the industry's history. And today we'll be talking about how digitalization is changing how cars are designed, how they're built and used and optimized. And car manufacturers obviously have to transform into digital enterprises to master today's challenges. Maybe you could tell us what that exactly means, Magnus.
Sure, I do that. But I'd like to add, though, that this digital transformation certainly not only applies to the car industry, even though we're talking about it. I mean, it's essential for all types of industry, more or less. But back to your question, to become a digital enterprise, it essentially means, from our point of view, that you're combining the real and the digital worlds, or perhaps even better, the life cycle of the product and the production. If you join the two life cycles, design, realize, optimize, you create a flow of data from product development to manufacturing planning through production, etc., and so on and so forth. And this means that the stakeholders involved in the development of the product or the production will get access to data at any given point in time so that they can make decisions in confidence, if you like. You have information that you can base your decisions on. So you have what we can call a horizontal integration from the design office to production, but you also have a vertical integration. One could say you're connecting the top floor with the shop floor, or IT with OT. And this is, I would say, something that's important for a digital enterprise. You get a transparency, you know where data is, you can track quality, etc. And to summarize it, a digital enterprise is collecting data, understanding data, and using data to continuously optimize everything they're doing.
Now, you obviously need to use hardware and software to combine design and production life cycles. And only then, in combination with the digital twin, can the magic happen. And a powerful software component for the design phase is Simcenter. And I know, Katrien, you've been using the software in a project called SimRod. Can you tell your listeners what this is all about?
As Magnus was explaining, it's about digital integration, but it's also about the sufficient verticals to really resolve design optimization aspects. And so I come indeed from the simulation and test domain, where we help our customers drive optimal performance for, amongst other, electrical vehicles. And so while, of course, now electrification is really breaking through, the OEMs, of course, have been touching the subject since quite some years. I mean, there has been a lot of technology innovation done on electrified vehicles using basically simulation and test. And The next challenge forward for these companies is, on the one hand, to keep addressing the difficult technical issues that there are to optimize such vehicles on the one hand. But as Magnus was also indicating, there is also the need for, shall I say, more front loading, adding digital twins in the development process, because, cost needs to be managed as well. We all know that electrical cars are quite expensive. And there is a lot of thinking about platform innovation specific to electrified vehicles, etc., etc. The SimRod vehicle is actually a sort of technology carrier for us, such that we can showcase our technology. And the SimRod is a fun sports vehicle, basically, with an e-motorization, fully electrical. And we showcase basically all of our digital thread technology and digital twin technology on that technology carrier.
So is the SimRod vehicle a vehicle you would exchange for your daily vehicle? Would you use it on a daily basis? Is it that fun to drive?
Not in the Belgian climate.
No?
We have a bit too much rain, basically, for that. No, it's an open vehicle, so it's an open frame structure vehicle. So it's really a fun vehicle, but actually with quite nice technology in the vehicle. And so we can showcase all of our digital twin technology on that vehicle. So
all right. Sounds good. Let's see how this all fits together with SimRod. I mean, starting with design. Maybe, Magnus, you can tell us more about the digital twin for products and how it fits together with design.
Absolutely. The methodology that Katrien spoke about brings, as you can tell, a load of benefits. Simulation is one of those items, but the digital twin has a lot more other things to it. We're collecting data in it. You have material. Everything can be kept in this digital twin of this SimRod. The most important thing for you as a driver is range. How far can I go before I need to charge it? And we used that as the scenario. And then we took advantage of the digital twin methodology by basically simulating everything we could on this SimRod, trying to locate areas where we could, for example, reduce the weight and make the car drive further. We had to collect data first. I think that's also important because I ever so often get the question, how do you make sure that the digital twin acts like the real product? In this case, Katrien's team, they were driving on a very cold day outside Leuven in Belgium on a cobblestone road, collecting data. And then took the data into Simcenter, analyzing it, understanding the data, and then that Simcenter solution showed areas of optimization. One area being what we could call a steering knuckle and suspension system, which is basically a heavy metal. But we were able to reduce the weight thanks to the digital twin, simulating it, analyzing it, and then could cut off 30% of the weight, yet keeping the same stability of the steering knuckle. And the solution we use is also amazing. It's called generative design and topology optimization, which means that you are mimicking nature's way of constructing trees and bone structure. So very stable and very lightweight. But when you have this type of organic structure, it's obviously important to check that this new design also fits in the car, right, Katrien?
Yeah, absolutely.
So there we take it and we use the digital twin to validate the new design to make sure it actually meets the requirements of a car, because you don't want to fiddle around with stability and security.
And on that project, we were experimenting on using additive manufacturing technology to produce that component. You look at really an optimal design in a much more open framework, open manufacturing possibility framework than traditional casting methodology. And so it means that you can indeed create shapes through metal printing process in this case that are far beyond what the traditional manufacturing methods can do.
A better design for the steering knuckle, okay, has been established. So we got that. All right. Done with design. Now it's time to move on to production. What happens now? What role does the digital twin play when it comes to production, Magnus?
Katrien touched upon it with additive manufacturing. And as Katrien also said, you could cast this part, but that probably wouldn't be as efficient at using, in our case, the additive manufacturing methodology, which basically is printing steel or any other material. I think additive manufacturing may be the coolest thing since sliced bread. was invented. Additive manufacturing technology as such is opening up new ways of doing things. And we say that if you can dream it, you can make it. I think that kind of comes very close. I think this is what we mean by that type of thing, because it's so cool, totally cool. And I when I was younger, I used to work in a factory on a shop floor where we used CAD/CAM, CNC. So this, I've kind of followed this for the last, I'm not going to say how many years, because then you know how old I am, but for quite some time. So that is the one thing that we can do with the manufacturing, but also additive offers flexibility, but so does also if you take the next step, because you need to assemble the product. And for that, obviously Siemens has been in the game for a very long time. We have the TIA portfolio with all types of automation systems and solutions that you need for a complete automation of a production facility, including communication, obviously, also.
So we've been talking a lot about the steering knuckle so far, but there are many other aspects and components, obviously, when it comes to an electric vehicle, like SimRod, to profit from digitalization. What are some of the highlights, Katrien?
Magnus focused a lot on improvements on the weight reduction side, but still keeping the performance. But obviously, I mean, the core of an electrical vehicle is the e-drive system, right? And the e-drive system is the e-motor, the transmission system, the inverter systems, and the whole electronics that comes with it, electrical wiring that comes with it, the batteries. So the e-drive system in its own right has been an enormous game changer. And the prime performance, of course, is efficiency and range, to cover the range anxiety that also Magnus pointed to. That is, of course, has been a lot of investment in digital twins to support that. It's complex systems, and you want to evaluate these complex systems in a vehicle context. And that's why we have a strong system modeling approach, that really addresses performances like efficiency, but also acceleration, feel, and the fun to drive element, and also the trade-offs that you have to make basically early on in concept with the systems choices versus the performance side. So there we have massively worked on system simulation technology to address such issues. But also, range is affected by aerodynamics. Aerodynamics remains a very, very, very important topic, but also the total energy balance of the vehicle during driving operation. It means when you drive vehicle, of course, the performance side is a main element, but also other things like the cooling systems. The batteries need to be cooled to have optimal performance and lifetime. So the whole balance between thermal systems and performance basically is an enormously important balance during the development process. And so we have been strongly working on connecting system modeling with CFD approaches and thermal approaches to address in different stages of the digital twin during the development to address the challenges in that. The battery in its own right is a challenge. The cell side, how to integrate the cells into a total battery, how to look at the performance, how to integrate it in the system level. Those are all elements that are extremely important in digital twin development for electrified vehicles. Yeah.
So many things to think about. That's amazing. And besides all of that stuff, we have to think about what else does the passenger need and look for. We're talking about comfort, for example, of the driver and passengers, right? By minimizing noise, by minimizing vibration. How does the digital twin help to tackle challenges like these?
It's an important point you make there because, in the beginning we said, electrical vehicles are smooth to drive and fun to drive. But there has been work done on these vehicles, to get them there. When you look at an e-motor, an e-motor is completely different in terms of its noise and vibration characteristics as compared to a traditional combustion motor. So an electrical system is more silent, than a combustion engine. And so it means that on the one hand, of course, you have that silence, but that creates its challenge in its own right because you start hearing as a driver much more other noise sources in the vehicle, like the HVAC systems, like the aerodynamic noise, the whistling around the vehicle, like also transmission noises, inverter noises, the whole electrical system also makes noises and so on and so on. And so you perceive basically other type of noises. So the whole noise balance has changed in electrical vehicles. And so people have been really concerned about it.
So are we moving towards a scenario where you're going to design just design and noise to distract from all the other stuff, maybe? You know what I mean? Like some kind of noise we can all agree on, which is like, oh, it's just there.
Absolutely. But you mentioned an interesting subject because, also electrical vehicles are very silent at the outside. Yeah. So it means that in low speed conditions, in urban conditions, pedestrians don't hear the vehicle coming. So there has been regulatory changes such that noise systems are put in the bumpers of these cars to have a minimal noise emission, such that the safety is guaranteed. So those are all elements that play a role there. And so active technology and controls technology is also used even in areas like the noise side. And yes, we work, for instance, on digital twins, digital listening twins, such that designing engineers can listen to the vehicle before it is built.
And I guess all of these aspects play a huge role when it comes to autonomous driving. Maybe you can tell us more about where the digital twin comes into play here, Magnus.
If we take a look at the distance required to get a car certified for autonomous driving, I believe it is the equivalent of going from Munich to the moon and back to Munich again. So it's a long drive. So what we can do instead is to work with a digital twin methodology. And one thing that's really cool that we are working on now is to create a digital twin of the chip that goes on a digital twin of a PCB, printed circuit board, that we put in a digital twin of a vehicle that we have built in a digital twin of a factory and can drive in a digital twin of a city and try the car out with all the things that Katrien mentioned before. So drive the car in this virtual city and try different scenarios. And that technology obviously saves a load of time and can train the systems to react like a real car. So we call this chip to cities, which essentially covers all the steps from a chip design, because the chip also plays a very important role in getting the range of an electrical vehicle up to speed, how far you can drive. So it's a holistic approach, I'd like to say, systems of systems acting with each other, sending information from one little device to another, taking the decision, what should I do next, etc. And this is cool. We could probably dig down in this forever. And I'm really looking forward to the autonomous driving when it gets out there, because I'd sign up immediately for that part.
Yeah, absolutely. Sounds exciting. Sounds a bit of like how the brain works too. You know what I mean? Like one system taking care of the other system, making sure that happens at the right time and so forth. Pretty cool. Katrien, what can you tell us about autonomous driving from your perspective?
Autonomous driving is very exciting, but it started also in steps. We know that actually the active safety assist systems are there today on many vehicles, and the level of sophistication on these active safety systems is increasingly dramatically. Even before officially being autonomous, it is still a very advanced active safety systems which are close to autonomous, basically. And it means that also companies have been working strongly, not only on the more global issues, as Magnus was explaining, but also on the more vertical issues. I mean, really making a digital twin of an autonomous vehicle, has many technical aspects to be resolved. And how to model and properly represent those millions of scenarios you need to test the vehicle in to have sufficient certainty that the systems will be functioning properly with all of the environmental changes that can happen, pedestrian crossing the roads, bicycles there, all kinds of aspects, and how to model also properly the environmental input, how to properly model all of the complex sensor systems and actuation systems. I mean, the camera systems, the LiDAR systems, the radar systems, and so on the car. And then how to do that efficiently in development process. I mean, there are many, shall I say, system technical challenges to the real validation of such autonomous vehicles. And for engineers, a real fun time, because there is so much interesting technical topics also to be addressed and treated in this digital twin journey. It's exciting for the Simcenter team as well to be working with our customers on that trajectory.
It's something that's probably not going to be solved in, let's say, the next 2 or 3 years. Looking at the time, I think it's up once again. So I'd like to thank both of you, Katrien, for joining us for the first time. I hope you liked it.
Yeah, sure.
And Magnus, thank you for joining us once again. This is becoming your second home, I guess, our podcast here.
Yes, it is, and I think it's great fun talking to the two of you.
Yeah,
I like
we should talk to the responsibles. Maybe get a longer session in at some point. But nevertheless, this wraps up our session here today. So thank you very much. Thank you also for listening out there. The digital twin is really shaping everything around us. I think we can agree on that. And it'd be great if you stay tuned for our next episode. If you want more information, just go to siemens.com/digital-enterprise. Again, this is Talking Digital Industries. I'm Chris Brow, and join us again soon.